Okay, so continuing on with our study guide here, number 9, convert the following values to feet per minute. So these were our conversion factors. So 5 yards per, right, means division. So I'm going to put the division sign per 1 second. And we want to make this into feet per minute. So that means we need to go from yards per second to feet per minute. So we're going to have to do 2 conversions because we have to convert yards to feet and we have to convert seconds to minutes. So we're going to go ahead and do that. So let's do yards first, right? So remember when we did our conversion factors, we went like this. So 5 yards, I want my yards to become feet. And remember, this is like the idea of multiplying by the big number 1, right? I can multiply by 1 and it doesn't really change the value of what I have, it just looks different. So yards to feet, so I know that 3 feet is 1 yard, right? 3 feet and 1 yard are equivalent. So if I make a fraction like this, it's like multiplying by 1, but the units will cancel out, which is a good thing. So now I have feet on top, which is what I want, but I need to make my seconds go to minutes. So I'm going to do another conversion factor where my seconds are going to become minutes. And I know that 1 minute is 60 seconds. Right? So seconds and seconds, the units cancel out, and now I'm left with feet on top and minutes on the bottom, which is exactly what I want for my units. So I just multiply my numbers across the top. 5 times 3 is 15 times 60. Let's go this way. That would be 60 times 5 is 300 times 3 is 900. I like that better. So you got 900 on top and 1 on the bottom, right? 1 times 1 times 1 feet per minute. All right. Part B, 18 inches per second. All right, and again, we're trying to go from inches per second, and all of these are trying to go to feet per minute. So let's do another conversion factor. This time I'm trying to change my inches to feet. And so my conversion factor to make this a big number 1 would be 1 foot and 12 inches. Those are equal to, those are equal to each other. Inches and inches cancel out, and I'm left with feet, which is what I want. And I got to do one to make my seconds go to minutes. So seconds to minutes, 60 seconds for 1 minute. So now I'm going to multiply across the top. I could reduce these first, but I'll just keep it simple and going across the top. 18 times 1 times 60. So that would be 1080, I think, right? Seconds. Only units left here, right? Oops. I screwed up, hold on. Yeah, I didn't cancel them out. So I canceled here my seconds with my seconds. So the only units left are feet and minutes, which is what I want. So 1,080 feet per 1 times 12 times 12 is 12 minutes. Then I can reduce that. And I would get 90. Oops. $90 feet per minute. So these are a little bit tricky. Let's do one more. So this time I'm going from 220 yards per hour, and I'm still going to feet per minute. So I'm going to take my yards and they're going to become feet. And I know from above 3 feet is equivalent to 1 yard. So the yards cancel and I'm left with feet. And I can go with a conversion factor that changes hours to minutes, and I have to cancel the hours out here, right? 60 minutes is 1 hour. So if I multiply these across, right, by 220 times 3 times 1 would be 660, and the units that remain are feet per 1 times 60 minutes. Right, so that's my feet per minute, but I can reduce that fraction right there. 60 goes into this 11 times, it looks like. 11 feet per 1 minute. Right. If I were actually doing this myself, I would go, once I was about to multiply, I would cancel this 3 with this 60, and I'd make this a 20. And then I could see maybe it goes in 11 times, but we'll go straight across for now. All right, so 10. These are kind of probably where we're more comfortable solving linear equations. We've done tons and tons of these. Okay, so number 10, linear equations can have one solution, no solutions, or infinite solutions. For the following equations, determine if there's one, none, or infinite solutions. So we have to actually solve the problem and find out, what the answer is, and then get as far as we can, and then that'll tell us if there's a solution or not. So let's just go ahead and solve these little two-step equations. They're pretty easy. So add 3 to both sides. I have 15x equals 30. Divide both sides by 15. X has to be 2. All right, so x is 2. If I get an answer, like x equals 2, a number, right, then that means there is a solution. Right, and I actually know what the solution is right here. All right, over here, we have to distribute on this side. So 7x plus 2 equals, and we combine like terms on this side. 3x and 4x is 7x plus 14. And if I subtract 7x from both sides, I end up with those cancel, and actually those cancel, so I'm left with 2 equals 14. Right, so if I ever end up with an answer like this, where I get two numbers equal to each other that are not actually equal to each other, like 2 equals 14, that's not true. That means there's no solution. There's no number I could plug in for x that's ever going to make that true. All right, C. We're going to do kind of the same thing. We're going to come here and we're going to combine like terms. So on the left side of my equation, I can combine these two. So 4x minus 2x, I'd have 2x plus 1. And on this side, I can combine this one and this one. So I'd have still the 2x from right there. And then 4 minus 9 is negative 5. So, that's good. So same thing, we're going to get all the x's on one side. So let's subtract these two and subtract these two. And when I do that, actually both cancel out, and I'm left with 1 equals negative 5. Right, so just like the last one, that's not true. So that means for C, there is no solution. D, same thing. Let's figure this out. Distribute over here. 8x minus 4 equals 36. Pretty much if the x is on one side, then for the problems we're seeing, there's almost always going to be a solution, unless it's like in the bottom of a fraction or something. So if we add 4 to both sides, and we already have the x's isolated, so let's get all the constants on the other side. So that cancels out. 36 plus 4 is 40. And then I divide away the 8. X equals 40 divided by 8 is 5. So D, there is a solution, and the solution is x equals 5. And the last one of these types of problems, let's keep on going here. Draw my line so I make sure I do things equally on both sides. So on the left side, I can combine these two right here, right? So I still have this 3x, but these two constants that I underlined can be combined. Negative 4 and negative 1 is a total of negative 5. And over here, I can combine these two. Right? So 2x and 2x gives me 4x, and I still have the plus 1. get all the x's on one side. So I'm going to subtract those away so they cancel. I have to do it equally. Negative 5 equals 1x plus 1. And now I subtract away this 1. Negative 6 equals 1x. So E did have a solution. So there were none there that had infinite solutions. Infinite solutions would be if I had the exact same thing on both sides. So if I have a problem and I work it all the way out and at the end I get something like 7 equals 7, that would be infinite solutions. All right. So just to go back to that idea, right? If I had something like 2x plus 1 equals 2x plus 1, it's the exact same thing on both sides. So I can tell as soon as I see the two sides are exactly the same, I know there's infinite solutions. All right, so number 11, there is an infinite number of points or solutions. Remember, when I graph a line, what that really is showing me visually all of the solutions, all of the combinations of x and y that make the equation true. So there's an infinite number of them, including all the decimals and fractions and so on. So name 5 ordered pairs that are solutions to the equation y equals negative 3x plus 2. Graph the line and place the 5 ordered pairs on the line. So I think what's probably the easiest thing to do is make a table. All right, so it's asking me to pick some. So let's pick them. So let's pick easy ones. 0. Well, let's pick even before 0. Let's pick negative 2, negative 1, 0, 1, and 2. I can pick any value I want, but let's see what I get. So oops, what happened here? I'm actually going to make this table a little bit wider. So we can show our work so you can see what's happening here. So we have our equation, right? F of x or y equals negative 3x plus 2. So I'm going to replace every single time. I'm actually going to do it this way. Maybe you'll see what's happening. Here's our function machine. And I'm just leaving the parentheses empty where the x goes. And then, right, these are my x's right here. I'm going to plug in whatever the x is. So this one's negative 2, negative 1, 0, 1, 2. Right? I can change whatever x I want. That's the input. It's my choice. Then I have to run the numbers and see what it gives me. So let's figure out what comes out. So if I plug in a negative 2, negative 3 times negative 2 is positive 6. Positive 6 plus 2 is 8. Next one down, negative 3 times negative 1 is positive 3, plus 2 is 5. Negative 3 times 0 is 0, plus 2 is 2. And if I look what's happening here, right, I know from a linear function, right, the change in y over change in x is the slope. It should be going down by 3, right, and that's what's happening here. So negative 3 times 1 is negative 3, plus 2 is negative 1. Negative 3 times 2 is negative 6. Plus 2 is negative 4. So they're all going down by 3. Right? I could figure out the next one down here would be negative 7, and negative 10. We keep going. So there's an infinite number of solutions. Plot them. So we're going to go ahead and write our. We came up with, if my x is negative 2, then my y is 8. We came up with negative 1 and 5. We came up with 0 and 2, 1 and negative 1, 2 and negative 4. Those are just the points that we came up with. So then it asked me to graph them. I like to start in the middle. So we know we did this one, 1 and negative 1. 2, 1, 2, and negative 4, right? You can see where they all are. So if I graph them, whoops, let me go through there. I can't fit a couple of them on there, like negative 2 and 8. It didn't have enough boxes, but that's how we would do that. And yeah, there's a lot of problems on this next page, so we'll do another video for those ones. All right, we're going to do another video starting with number 12, and we'll pick it up from there.